Hello everyone and welcome to lesson 16. We're very glad to see that you join us today. Okay, starting off with project talk. As we've discussed in previous lessons, you guys have teamed up in groups of 2 to work together on your course project. We have listed here the people who said they're in teams. The last 3 people aren't on their own. They're going to be doing projects on their own because they couldn't team up. If anything happens that you need to change your team, please let us know and we can change things for you. Also, please note that the last 30 minutes of every lesson from lessons 15 to 18 will be dedicated to project time. So you can work on your project in that 30-minute period, ask us questions and ask your fellow classmates for help as well. We are also dedicating the whole of lesson 19, so the second last lesson of the course. We are dedicating the whole thing to working on your project and making sure that it works 100%. Alright, based on questions we had in our last lesson, we've created some extra videos on our YouTube channel. There are 3 of them. The first one relates to backgrounds and how to import them into your project so that they are on your stage. James raised a good point that sometimes he imports a background and he lands up with bars on the sides or on the top and the bottom, and he wanted to know how to overcome that. So if you need to figure that out, please go to our YouTube channel and check out that video. All 3 of these videos are less than 10 minutes each, so it won't take you a long time to go through them. The longest video, which is just under 10 minutes, is actually the join block. That's quite an important block for you guys to know how to use. A lot of you struggle with that, so please check out that video. It will definitely help you with your project work if you're going to be joining strings together. The third video is the import or export and import of code. Because you're working in teams on your project, you will need to share code which you might work on when you are not together. The video on export import shows you how to use a sprite to export your code and import it into another video. If we have a time at the end of this video, we'll go over it again quickly as well, just so that you know how to do it. Alright, last time in our previous lesson we explored the repeat until, which is over here on the right, and the forever blocks. They're quite similar to the repeat number loop, which we've been using for many lessons now. The repeat until is also known as a conditional loop because it has a condition in this hexagonal block which must be met before the loop will stop, whereas the repeat number block is actually a counter loop and will repeat regardless the number of times that you enter over here. The repeat forever loop doesn't depend on anything because it continues forever, so there's nothing to stop it from running except if you actually stop the program. You'll see the actual difference here is that there's a bump underneath the repeat count block and a bump underneath the repeat until block, but there's no bump under the forever block, which means you can't put any code blocks underneath the forever block. They all have to be inside the forever block. We did 2 exercises in the last lesson. The first one was the times table machine, where you had to ask the user to enter a number, and then your program would then go and say the times tables for that number from 1 to 12. So for instance, if you entered the number 3, it would then say on the screen 1 times 3 equals 3, 2 times 3 equals 6, 3 times 3 equals 9, all the way up to 3 times 12 equals 36. What was quite interesting with that exercise is you could put in any number. So you could get the 20 times table or the 457 times table, because for a computer it's pretty easy to do any times table. The second exercise we did was the addition test, where we got the computer to randomly choose 2 numbers less than 50, and then it would ask you, the user, what the sum of those 2 numbers were. So for instance, if the computer chose 20 and 15, it would ask you, 20 plus 15 equals question mark, and you would have to type in the answer. If you got it right, you would then be allowed to proceed and the program would exit. If you got it wrong, it would carry on prompting you for the correct answer until you got it right. Now both of these exercises illustrated for the times table machine how to use the repeat count block, because we went up to 12 for each times table, and in the addition test we used the repeat until block because it repeated asking you what the answer of the sum was until you got it right. We also touched on the stop script, or the stop code block, which we use to stop the execution of a program. It has 3 different flavors. It has a stop all, where it'll stop all scripts in your program. It has a stop this script, which will only stop the script that the stop block appears in. And it has a stop all other scripts, where it will stop all the other scripts in your program except for the one that has the stop block in it. The exercise we used to show how that works had 2 colored balls busy chasing a witch on a broom, and when the green ball touched her, the green ball stopped, but the red ball carried on, but it doubled its speed, and when it touched the witch, then the whole program stopped. Alright, today's mission, we are going to do 2 things. We're going to validate user input, and we are going to explore how to use counters. Now on the right hand side here, we see a typical what we call form, which you will come across in a business application or on a web page on the internet, where you have to supply your personal information. So name, email address, phone number, address, and credit card number. Now you can see what has happened is the user has put in some values, so Hurley for email, ABCDEF for phone, and 1111 for the credit card number, and then they clicked on the submit purchase button. The program was clever enough not to just accept the input that the user typed in. It did some checks, and then it came back to the user and said these are your problems, which it has put in the red letters below each field. So in the case of the name, the field is required, so the user has to put a value in there. In the case of the email, Hurley is not a valid email address. An email address typically includes an @ symbol as well as 1 or 2 full stops to make it a valid email address. Phone numbers, as you know, only contain numbers. So ABCDEF isn't going to be valid, and we know that phone numbers also have to be 10 digits in length. So this phone number is not a valid number. Addresses, well, first of all, no address was supplied, so that is automatically invalid. But we know that addresses can get quite tricky. You can have street numbers, house numbers, suburbs, cities, postal codes. Here, the developer of the program chose to only supply 1 line to enter all of that, which makes it more difficult to validate, because it's easier to validate things if you only have to check one thing. So you'll see very often an address field is broken down, as I said, into street number, house number, suburb, city, province, that kind of stuff, because then we can validate individual things. And when I say validation, I mean that something is valid. So valid is correct, or the right answer, or what we are looking for. Invalid is incorrect, or wrong, or not what we're looking for. So when we ask for a phone number, we are expecting a number, not A, B, C, D, E, F. So that is why it is invalid. In the last field, we have a credit card number. Now, they've put in numbers, but they haven't put enough numbers in, because credit card numbers have 16 digits. And they also obey certain rules based on who the credit card provider is. For example, Visa, MasterCard, or American Express. There are a lot of rules that can be applied to validation. We won't focus on the really complicated ones, but we are going to go over why you need to use validation. The second thing we're going to look at today is the counters. What you see here is the counter which gets used in sports events. So if someone is trying to count how many runners are passing a waypoint in a marathon, they would use this device. It's a small device that fits into your hand, and it's got a little button here that you press. And every time you press it, this counter ticks up by 1. That is a very common thing that we use in computer programs. We actually used it in the times table example in our last lesson, where we used a counter to count from 1 to 12, which we then multiplied by the number that the user typed in. Alright, let's go over some validation concepts. This is more of a formal definition of what we've pretty much covered on the previous slide. So when it comes to validation, we need to know what kind of data types we're working with. Typically we are working with numbers and strings. So as we saw in this example, we have got phone numbers and credit card numbers. So we know those will definitely only contain 0 through 9, whereas an address, or an email address, or a name will most likely have, as the majority of its data, will be letters. So ABC all the way through Z, plus space, punctuation, and so on. So depending on what our data is, we can make a determination of what kind of data type should be used for it, either strings or numbers. Ranges, okay, bigger than this and or smaller than that. A typical range would be height. If you are a normal human being, your height, depending on your age, is somewhere between half a meter, which is most probably how long a baby is from head to toe, all the way up to maybe 2.5 meters if you're a really tall basketball player. But if someone put in that their height was 6 meters, you would definitely know that that is not true, because unless you're an alien or a freak of nature, there's no way that you're going to be 6 meters long. In the example on the right here, we can see that the list price must be between 0 and 5,000. So we can see here they put in a value of minus 9.5. Minus 9.5 is less than 0, so it does not fall in this 0 to 5,000 range. Another thing we can use with validation is length. Something can't be longer or shorter than a certain number of letters. Okay, if we go back and have a look at the previous slide, we said credit cards have to be 16 digits long. Telephone numbers have to be 10 digits long. But we can use it as well for name. A name must be at least 1 character. An address must be at least 1 character. We can't say how long a name should be or an address, but we know it should have at least 1 character in it. Then we have dependencies. Now dependencies are interesting, and sometimes it takes a bit of insight into the information you're trying to store to figure out what they are. A common dependency is city and postal code. So for example, if you say that your city is Johannesburg, then your postal code should be 4 digits and must start with a 2. So if your address is in Johannesburg itself, your postal code will be 2000. If your address is in Randpark Ridge, for example, then it will be 2196 or 2169, beg your pardon. Other cities have different postal codes, which are all 4 digits long in South Africa. So for example, Cape Town has postal codes starting with 8, so they're the 8000 range. Durban has postal codes starting with 4 in the 4000 range, and postal codes below 1000 are actually in Roodepoort. So you can see there's a dependency there. One of the ways we make validation easier for us is we limit the options that we give to the user. So instead of letting them type in values like we do over here, we force them to choose from a drop-down list. Now if you click on that little arrow, it'll drop down a menu which will have a list of things in it. By only allowing the user to select from a predefined list, it greatly reduces the amount of validation we have to do. It basically reduces it down to, has the user selected something from the list? And that's all we need to check, because we will be providing the items that appear in the list. Now let's look at this exercise on the right here. It says the product number is not in the correct format. We have a product number of -B909-L. Now first off, we don't know what their product number format is, but we can imagine that having a minus in front is most probably not valid, or having any minus in it might not be valid. If we had to guess, their product number Might also not allow letters, but let's not get too carried away there. The second one says the standard cost is not the correct format. Standard cost is 3.399. Now if you imagine this cost to be in rands, that would mean it's 3 rand 39.9 cents. Typically we don't have prices down to the third decimal point. So this part of the standard cost is too long. So it should be a number which can be anywhere from 0 to 5,000 on the list price. So we can imagine the cost price is similar, and we would only have 2 digits to the right of the decimal place. So correct value would be 3.39. Then we say the list price is not in the correct format. As we've discussed, it's negative. It needs to be between 0 and 5,000. So being negative means it's less than 0, which makes it invalid. Validation is a very important part of computer programming because you can't always trust what users put into your computer program, and if you don't check it, the values they provide can actually cause your program to crash or work in ways that you didn't intend it to. So let's explore this a bit more with an example. Here's an example of how we would validate the level that a user chooses when playing a game. So if we go into our Scratch editor and we have a look at it here, we've got 2 blocks of code. We've got the when green flag clicked, that calls the get level custom block when we jump over here, which asks you to enter a game level 1 or 2 and wait, which then gets saved in the answer variable. Now normally that's all we would do, and then we would say join you chose level and the answer. But if they put in ABC as the answer, your program's not going to work because you don't have a level ABC, you have a level 1 and a level 2. That's why we use this repeat until block to do some validation, and this block repeats until the answer is equal to 1 or equal to 2. If it's not equal to 1 or 2, then that says the program says invalid entry, please choose either 1 or 2 and wait. And then it goes back into the loop and it checks your answer again. So this block here, this repeat until with this condition in it, prevents you from putting in the wrong value for your level. Once you exit this loop by entering the right answer, then we jump back to the say block here, which says you chose level and whichever level you chose, 1 or 2. If we see this in action, it says enter level 1 or 2. We're going to say level A, invalid entry, please choose either 1 or 2. Let's enter level 4, still invalid entry. Let's enter a whole long thing, still invalid. Let's enter 2. You chose level 2. So there you can see that is how we do validation in a very simple way. Okay, now we're going to do an exercise. Okay, we are going to enter the right code. So like we just did in the game level example, we're going to make it a bit more complicated. We have to write a program which asks for a code word that starts with the letter C or K and is 5 characters long. The program must validate the user input. If the user enters an incorrect code, they must be prompted to try again. If the user enters the correct code, then the program must say welcome to the club. So you'll see there are a list of blocks on the right hand side there. We are going to definitely need to use all of those blocks plus maybe a few more. Some of the blocks that might not be that familiar to you are the length of and the letter of blocks. Those are used on strings to get the length of the string or a particular letter within the string. And you'll see how that comes together as we build the program. So let's jump back to our Scratch editor, go File New to get a new program, and then we're going to obviously start off with when green flag clicked, which is under our events. Okay, and then first off we need to ask the person to enter a code. So enter a code that starts with C or K and is 5 letters long. Alright, now we need to get our repeat block, which we are going to use to check the answer. So get our repeat until. There we go. And now we need to build up our check. And as I said, we are going to use our and our or, and we are going to use our letter of and our length of. So we know, and we need to use some equals. So we know that the length of answer, okay, must be equal to 5. So we put that in there. So there's our first check. We also know that letter 1 of answer again must be equal to C, or it must be equal to K. Now we need to join these up. So we need an or. So letter 1 must be C or K, and our length must be equal to 5. So there we built up our condition, and we go plonk it in our repeat until block. Now we've got a nice repeat until block. Okay, if the user gets the answer wrong, then we have to tell them, or the code wrong, we have to tell them they got the code wrong, and we have to get them to try again. So we are going to say wrong code, exclamation mark, and give them the instructions again. Enter a code that starts with C or K and is 5 letters long. Alright, now if they got the answer right, or gave us the right code, what we do is we go down here and we say welcome to the club. So let's run our program. Our cat asks us to enter the code. Let's enter some rubbish. It picks up we haven't chosen the right thing. Okay, let's try 1, 2, 3, 4, 5. Also wrong, because that was 6 characters long. Let's try 1, 2, 3, 4, plus the C makes it 5, and now we have been welcomed to the club. So that is how we do some basic validation using our repeat until block, as well as our letter of and our length of blocks on our answer that the user entered. Okay, and there is the program that we have just written. Okay, now we are going to do counters. Alright, counters track how often something has happened. As we said in our repeat until, or our repeat count blocks, it will repeat it however many times you enter the number in the space, but you don't know what iteration you're on as it loops through. So you will typically have to use a counter to keep track of the iteration. The most common counter is a loop counter. Example, the times table machine from lesson 15. As we've discussed earlier, we don't always count up by 1. We can count up in any multiple we like. So for example, we can go 2, 4, 6, 8, which is counting up in multiples of 2, or we can go 90, 80, 70, which is counting up in multiples of minus 10. So if we put a minus in front of the number that we are using for our count, we end up counting down. So 90 minus 10 is 80, 80 minus 10 is 70. And both of these patterns are very useful. Okay, the important thing is that counters must be initialized. and that means we set them an initial value or a starting value before we start using them. In Scratch, your counters usually initialize to 0, but in other programming languages you can't be sure what the value will be of your counter, so you have to make sure that you give it a starting or beginning value. Alright, at the top here you can see we have a change counter block, which is what we use to increment the counter. Increment means send it to the next value. So increment by 5 would go 5, 10, 15, 20, and so on. If we were doing this one over here, we would increment by 2. If we were doing this one over here, we would increment by -10. Alright, now we're going to jump into this example. It should be on your flash drives. It's called passwordcheck.sp2 from sessions 13 and 14. Let's go load it up in our Scratch editor. So file open, not saving that one, and there's password check. Alright, now in this script what we do is we've got a computer on the right or left here which we are trying to switch on. In order to switch it on successfully, we need to enter a password. So we've got two code blocks here. The first one starts when the green flag's clicked. The second one is a custom code block. So when we start, we switch the computer costume to the off costume. So if we go have a look at our sprite's costumes, it's got an off and an on costume. And then we call the get password custom block. Now as you can see, we have got two variables here, fail count and got pass. Got pass is used to track whether or not the user has entered the correct password. Got pass is initialized at the top here to have a value of 0. 0 means false, 1 means true, so it starts off saying that got pass equals false, so the user has not entered a correct password yet. Our other counter or variable is called fail count. Fail count is also set to 0 when we start, and that is used to track how many times the user has entered an incorrect password. If they enter the incorrect password more than 3 times, then we exit the get password loop and we show them this message here which says access denied. As you can see, you get 3 turns to try and enter your password over here. Every time it asks you password and waits, you type in your password, it puts what you type in into the answer variable. We have a if then block, or if then else actually, and it checks if the answer is equal to pass 1, 2, 3, then got pass is set to 1, and we stop the script. If we stop the script, it jumps back here and it checks the value of the got pass variable. If it's equal to 1, which it will be if you enter the right password, then it says access granted, and it switches the costume of your sprite to the on costume. If you entered the wrong password, it goes to the else branch and it says change fail count by 1. Then it does a check if fail count is less than 3. So remember, you get 3 turns to try and enter the correct password. It says invalid, try again. And then you loop comes back up here and it asks the password and checks your answer again. If you don't get the right answer, then fail count excuse me, will exceed 3 and this loop will no longer continue, and your got pass will stay at 0, which is what you initialized it at. If got pass is equal to 0, then we jump to the else and it says access denied. So let's try run our program. Password, we say pass 1, 2, 3, access granted. If we try it again and we enter nonsense password, invalid, try again. Nonsense password, invalid, try again. Nonsense password, access denied. One thing to note, if we type in pass with a capital P, we get in. If we type in pass with a small p and make the s's capitals, we still get in. The reason for this is that Scratch is not case sensitive. Now case means uppercase and lowercase. So Scratch doesn't care if you have a big P or a small p, big A or small a, as long as you have a P, A, S, S, either uppercase or lowercase, it'll see it all as the same and let you in. Right. Now we're going to do some counting up and counting down. Okay, this is pretty much the same thing we did in our times table exercise last week, but we're going to do it here quickly again to show you how to count up in fives. So let's go back to our editor, go new. Alright, and we're going to go get our when green flag clicked, and then we're going to have two variables, and we're going to call the one sum and we're going to call the other one count. And remember, I said when we start using counters, we have to initialize them. So we have to set count and set sum to 0. Now we are going to have our repeat until block, and we have to put a condition in there. And the condition is going to be until count is greater than 20. So we go get our count variable, and we put in 20 here. And then we have to start adding some things up. So we are going to set our sum variable, not count, equal to sum plus count. Remember, sum and count both start on 0, so the first loop will be 0 plus 0 equals 0 for sum. So let's go get our variables, sum plus count, and we put that in there. Now we need to make sure that we increment our count, and we are going to increment it by 2. For example, sorry, that must start off at 2 as well. I actually think the example on the slide was actually 50. Alright, and then when we are all done, we are going to say the value of sum. Okay, and there we go. 3355. And if we have a look at our values, they had counted up. Now if we wanted to see this actually happen, we could put a wait in our loop, make it for half a second. There we've got our variable monitors, and let's go. See, there it's counting up, the count and the sum. 335 is the answer. Alright, if we go back to our exercise here, okay, that's actually a bit different. We didn't have a sum in it, so let's go take the sum out. That's actually from another exercise. So let's go take our sum out. And let's take our sum variable out, and we're going to use count. So count, 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 and we're going to do that. And we are going to say count for 1 second. There we go. That's actually what we're looking for. So there you can see our cat is counting up by 5. Alright. Excuse me. Now we need to change the script to count down from 100 to 0 and 11s. So we need to initialize and set our count to start at 100, and we need to get it to stop when it reaches 0. So we have to change our greater than to a less than, put a 0 in there, and put that back into our repeat until, and there you go. Now we are going to change count by -11 if we want to count down. And then we run our script. As you can see over here, it's counting down in 11s, and when it reaches less than 0, it'll stop. There you go. Alright, next exercise, exercise number 2. We are going to add up the multiples of 2. So we need to write a program which adds up all the multiples of 2 together that are smaller than or equal to 20. So basically we are writing how to add up the 2 times table. So we are going to go 2 plus 4 plus 6 plus 8 all the way up to 20 will give us our answer. We are going to need a sum and a count variable, and we need to remember the pattern sum equals sum plus count. So we've got 2 variables, count and sum. We need a repeat until to make sure we don't go bigger than 20 on our count, and we need to set sum equal to sum plus count, and we need to change count by 2 because we're counting up in 2s, and then we're going to say the answer at the end for 2 seconds. So let's go back to our Scratch, go File New. We are not saving. First thing we're going to do is we're going to create our 2 variables, sum and count, and we are going to start off with on green flag clicked, and as I mentioned, we are going to initialize our variables. So we initialize sum and count. Sum starts at 0, count starts at 2. Alright, then we need our repeat until block, and then we need to put our condition in. So our condition is going to be count is less than 20. So 20, and we get our variable count, and we put it in there, and then we move it into our repeat block. Then we are going to set our sum variable equal to sum plus count, which was the pattern we had to remember, and then we need to increment our count by 2. And then once we have the answer, we are going to say that answer for 2 seconds. So we are going to say sum for 2 seconds. So if we run our program now, okay, we see it's not working too well. Alright, why would that be? So we've set our sum to 0, we've set our count to 2. We are repeating until count is less than 20. There is our mistake. It should actually be count is greater than 20. So we swap that out, put that back into our repeat loop, and let's try again. And there we go, the answer is 110. If we wanted to change it to another variable, say 3 and 3, okay, there's the sum of all the multiples of 3 less than 20. Okay, so that is the answer to that exercise. Alright, it is project time now. As I said earlier on, we are using the last 30 minutes of lessons 15 through 18 to work on your projects in class, so that you can ask any questions of myself or Mr. LaRue or your classmates. And then for lesson 19, we'll be using the whole lesson dedicated to project work. Please ask questions of us and your classmates, and please also show us what you've done so far. I know some of you guys want to keep it a bit secret, but it's much better to find out if you have problems or could do things a better way earlier than leaving it to the last minute and finding out that you might have a problem that you don't have enough time to fix. So remember, you learn more by sharing. Oops, wrong way. Okay, homework is obviously, as always, work on your project. Please check out our website for Lesson 15 information. Lesson 16 will have information, including this video, up available from Monday. And please also remember that on our web pages that we put up for each and every lesson, there is a PDF version of this PowerPoint that you have just been watching. So if there's anything you didn't catch in class that you want to see again, please go to these web pages and download the PDF, and it'll have all the information in it that you need. Next lesson we are going to cover a bit more about lists. We might revisit the encryption exercise we did a few lessons ago and go through it a bit more slowly so that you guys understand it. It's a really fun exercise to go through if you know what's going on. As always, please shut down your computers before you go, and don't forget to take your flash drives home. We hope you have a great week, and we look forward to seeing you at your next lesson. Thank you and goodbye.